Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the module FM350-1 read data from encoder by using the TIA Portal version 17 and use the incremental encoder model boomer. Yes. And in this section, we will read the data from this module. It is the high-speed counter module. So this is a connection of the encoder that connect to this module. And we will go to create the new project step by step and then read the value from the encoder by increase and decrease the value. Okay. And in this section, I will use the LAN cable connect from my PC to the PLC Profinet port of CPU 314C to PN/DP. Yes. Actually, this CPU it has built-in the high-speed counter also for this slot. But in this section, I will just show the example about how to read the data from the FM350-1. Yes. So before go to create the new project and test with the encoder, I would like to explain about how to wiring the encoder to the PLC. Okay. So let's go. So here is the overall drawing. I just draw with the connection of encoder to the counter module. So this is the model number of counter module and this is the encoder. So we will use 4 terminals for encoder. Yes, I mentioned in this slide here. We use UB plus A, B and 0 volt. Yes. So we will supply 24 voltage to the module to terminal number 1 and number 20, and it will parallel with the terminal number 2 also for the 0 volt DC, and we will use the connection number 5. Number 5 it means that 24 voltage DC. If we would like to use number 4, we can use with the 5 volt DC. Yes. And we will use the A connection. It means that the signal from encoder phase A, and B it means that signal from the encoder phase B. Okay. So we will use terminal number 1, number 2, number 5, number 6, number 8 and number 20. Okay. At the terminal we no discussion. Yes. And we have the function for select with the 5 volt DC or 20 volt DC also. So here if we select D, it means that 24 volt DC, and if we select A, yes, A it means that here. If we select 2 here, it means that 5 volt DC signal. So this one just example. If select D, it means that input 24 volt DC, and here is select A, it means that input 5 volt DC. So in this section I will select D. Yes, select to D. So this is just explain about how to selection the function of hardware configuration of encoder and then how to wiring. And next step we will go to create the new project and then test with the real PLC. Yes, so let's go. Okay, so first let's create a new folder, encoder, and then let's open the TIA Portal version 17. So wait a moment for open the software TIA Portal version 17, and we will go to create the new project step by step and slowly for easy to understand, and read the data from the encoder. Yes, and we can also simulation with the HMI. Yes, I will show step by step. Yes, so let's go to create the new project and put the project name, example PLC, or we can type FM350-1 encoder, and then browse to folder that we already created on desktop. So let's go to FM350 TIA with TIA. Yes, and then we can comment this project created for read data from encoder by using FM3501 module. Okay, so let's click create, and then the project will create it after we click. Yes, so wait a moment for creating the project. After that we will go to set up the hardware configuration of the PLC. Yes, okay, so first let's go to project view. Okay, wait a moment for open, and then let's go to device and network, or we can go to add new device. So double click add new device. Yes, and then go to controller, go to Schneider S7-300 CPU, and I will choose the CPU that match with my PLC. So 314C 2PN/DP version 3.3, and then click OK. So wait a moment for create the hardware configuration. Okay, and then let's go to add the network. We can check the network property. Yes, go to property, and then we can check the property here. So we have two port of Profinet. Yes, and Profibus. Yes, So right now we use the Profinet, so we can check the IP address 192.168.0.1. Yes. And next step we will go to add the counter module. So let's go to FM counting FM3501. Yes, this one. Let's see the PAN number should be the same here. FM3501AA03. So FM3501AA03. Drag and drop the counter module to the rail. Okay. And it will show the address here. Here is the address. Start from 256. Yes. Until 271. Yes. So this is the address. And then we can zoom. Yes. Okay, zoom to see the overall of module. So we have two parts of Profinet and one part for Profibus, and it is the analog input and output built-in and digital input and output also for the CPU. And we just add one more for counter module FM3501. Yes. So we need to download the hardware configuration to the CPU, right? But before download the hardware configuration to the CPU, let's go to see the counter property. So we need to set some parameter of this counter. So right click on the counter module and then go to parameters. So this one we can select as software get. Yes. And this one we use 0 to 32 bits. Encoder we will use the 24 A plus B. Yes. And we can use the default like this. And for the input we can use default also. Output no need to set, right? So this is just parameter, so we select only 24 or 5 volt. So right now I select 24 volt. Yes, and then save. And then we can compile the hardware configuration. And then we can download the hardware configuration to the CPU. Yes. So let me check the IP address of my PC. We will put the manual of IP address to be the same as with the CPU. Okay, 192.168.0.253. So we can download the hardware configuration. Select here and then click download. So wait a moment for scanning the PLC. So we need to select the PC interface here. I select with the Ethernet connection and then show all capability devices and then click search to search the PLC, because right now I already connected the LAN cable from my PC to the Profinet part of PLC. So right now it detects one PLC 192.168.0.1. I will load the hardware configuration. During load the hardware configuration, we will stop the PLC. So right now the PLC stop and I will restart again. PLC is started. And then we need to create the block for read the data from FM350, right? Okay, so let's go to save the project and then go to blocks, OB1, and we need to create the new block. Example, we create the data block. Example, counter 1. The block name is counter 1. And then we will choose the CNT chain type here, chain type 1. Yes. It means that counter channel 1, channel type 1. Yes. So click here. And then click OK. It will create the database automatically. Yes. So we will got this parameters. Yes. Automatically from the library. Okay. And then let's go to OB1 again. So I will compile the block first. Okay, no error occur. Error 0, warning 0. And then we need to initial the counter, right? Initial the data block. So right click and then choose the STL network. So I will delete the network 1 first. Okay, we use the static language to initial the block. Yes. So we need to know about the address of the counter, right? The first one. So let's go to check the hardware configuration again. Yeah, this one. Go to property and then check here. It is the address of counter, right? So 256. Okay, and then go to main again. So we can write as L space bar 256. It is the address. And then enter. This one is the name of the counter. So counter 1, name of database. And then dot mode address. Yes. Enter. L again. So P 256.0. Yes. And then T counter name. Yeah, counter. And then dot CH address. Yes, here it is the address. L16, and then T counter again, counter 1, yes, dot UD, okay, and then we can compile the program, yes, and save the project. So if we would like to read the data from encoder, we can use one more block. I will add, so this one, initialize initialization, the block, and then I will insert the network. This one, read data from encoder, yes. So let's go to library of encoder, yes, and then go to function modules, go to FMH counting, yes, here, and then we can use the CNT one, yes, so drag and drop, okay, we will go like this, or we can use the another blocks that support with the module, yes. So this one dB, I will use dB1 here, yes, so 1. So this one is all is boolean, so I will use M0.0. It is the switch gate, right? SW gate. M0.2. It is the gate STP. M0.3, M0.4, M0.5, M0.6, M0.7, M1.0, M1.1, M1.2, M1.3, M1.4, and this one M1.5, yes. So we can rename the tag as OTERRA set DOO set DO1 L direct L PREPAR TCMP V1 TCMPV2 CDOPARA or SYNC ERESZERO, and the last one is OTERR. Yes, and then we can save and then compile the program. It should be not error, right? So right now we compile finish, and then we can save again and then download to the module again. Finish, start the module. And then we need to reset the PLC to let the program is initialized, right? So let me reset the PLC. So wait a moment for turn on the power of PLC. This one maybe I write incorrect. Yes, this one should be 6. Yes, sorry, this one, and then compile again. Yes, we will download again because it is the address of encoder, right? So 256 here. I will download again. And then start the CPU. And then we can online, yes, to see the status. So wait a moment for online. Okay, and then we can go to check on DB1. Yes, we can online to check on DB1. Yes, so let me adjust the encoder, and then let's see the status together. I will adjust the encoder. Let me check the status. Let's go to check the hardware configuration again. property. Okay, that's correct, the address. And then let's go to see the OB1, and we need to turn on the switch gate, right? We need to turn on this one, so I will turn on the switch gate. True, yes. And let's check the OB DB1 again. Yes, this one should be active here. Yes, let's see this value. It will work. Yes, let's see the value is increase and decrease. I will adjust the encoder. Yes. So if I adjust the encoder, let's see the signal is increase and decrease. Yes. Yes. Increase and decrease. Follow our rotate. Yes. So it worked perfectly. Okay. And then we need to show this value on the HMI, right? So we can create the HMI, go to add the new devices, go to HMI, go to HMI, yes. I will use the comfort panel, 7-inch, and then OK. We need to show this value on HMI, yes. So wait a moment for create the HMI. Just click finish. Okay, so take time a little bit. And then I will delete all this one to put the content, right? I will put the content as FM350-1 read data from encoder using TIA Portal V17. Okay. I will change background to be another color. Yes. Okay. And for this one, I will use rectangle for content. And I will change the color to be this color also. And then change the text to be yellow center. I think 27 21. Yes, let's test 21 first. And before go to see the data here, we need to create some logic or some data to move to the PLC, right? So I will use the, okay, I will outline first. So actual value of encoder so I will convert from double integer to real, right? So instruction, and then I will use the empty, yes, empty box here, and then we can type convert, yes. I will convert from double integer, yes, to real, okay. And then this one should be this one, right? Yes, double integer here. So ACT CNTV, right? So CNT ACT CNTV, okay. And here we can use the memory that we would like to move, yes. Example, I will use MD30, yes. So this is a counter value. Or encoder value. Okay. And then we can save and then compile and then download to the PLC. Okay, finish. So we can online to check the raw value. Yes, right now minus 1060. Yes, if I adjust the encoder, let me adjust the encoder. Let's see the raw value is changed. Yes. Yes, raw value is changed. So we need to show this value on the HMI, right? So first let's go to root screen and we need to insert or add the text for MD30, right? So I will go to connection, yes. Add the new devices. So PLC1 encoder. And then I will use the Ethernet. So 192.168.0.253, it is the address of my PC. And this is the address of PLC, so 192.168.0.1, yes. And then we can go to add the HMI text. So encoder value it is the real, right? Because we already convert from double integer to real. Yes, so MD30. So real, use the divide, and the address is MD30, and we can choose the scan time or cycle time with the 100 millisecond. Yes, so when we update, it will show the status, follow the cycle time that we set. Yes, and then we can go to the root screen. If we would like to show the encoder on the screen, example, we would like to copy the picture of encoder, we can go to copy also. Okay, here is the picture that I already put. Yes, so I will copy the encoder picture to the screen and then paste. We will got the encoder like this. Yes, if we have any type of encoder, we can also copy. Yes, okay, and then we can show the signal of encoder here. Yes, so we can use, actually we can use drag and drop from here. Yes, so we can use drag and drop from the text to the screen. Yes, like this, or we can use the IO file from here. Yes, it is the same function that we can use. So go to property and then go to general and then drag and drop the text here. Yes, and we need to set the format. Yes, so example, the format is this one, should be output also, sorry, output only. So example 99999.9. Yes, we will go like this. So this value should be the same. So the first way we can drag and drop the text to the screen, and the second way we can choose the IO file and then use the drag and drop the text to the IO file, and then we can see it. Yes, so here we can go to property, apparent, we can put the color of field to be black, and for text color we can change to green, and the font size, text format, we can choose the center and middle. Yes, and we can adjust the size, yes, of number like this. This one also we can centralize. Yes, yes, So this number should be the same, and we can go to simulation. Yes, but before go to simulation, let's see, make sure we connect the or set the PG interface with the control panel. Yes, so go to control panel, go to set PC interface 32 bits, and make sure we choose the S7 online step 7. Yes, PLC SIM, TCP IP. Yes, because we use the Profinet cable or Profinet port, right? So I will simulation the HMI. So start simulation, and then we can adjust the skin later. It's not linked with the PLC yet, right? Okay, I will adjust this one a little bit. Adjust the layout of this one, and adjust the size to be 17. And I need to go to control panel to check the PG interface again. This one correct, right? Okay, choose this one, and then we can go to compile the HMI, and then try to simulation again. Okay, right now we can connect to the PLC. Yes, because the value is shown on the HMI, and then we can test like this. So first, let's make sure the switch gate is turned on. Yes. Okay. So let me adjust the encoder. Okay, we will adjust the encoder. Let's see the value is changed, increase. And if we would like to decrease, we can decrease. Yes. So the value is decreased also. Yes. And the LED is working perfectly. Yes. So it works perfectly for this communication. Yes. So I will delete one screen. Delete this one. Yes, because it is the same. And we can design the screen to be good looking. So first we need to put the switch gate, right? For the switch gate is M0.0. Let me explain. So we need to add the text more for switch gate. The first one we need to put the switch gate, right? So enable counter gate. It is the bool, right? Boolean. And M, it will start from M0.0, right? Here. M0.0. Okay. And if we would like to reset the counter, yes, we need to enable this one, reset for reset, right? This one. Okay, I will insert one more network for reset the counter. This one should be reset value of encoder. So far we need to turn on this bit, right? So M0.5. It is the set DO1, right? And if we push that button, yes, I will move the value. So move 0.0 to the counter, right? So DB1 ACT, right? So we can use this one. Reset the counter. Let's go to see the right value here. Command right? Write the command to counter. It should be right user, right? Right user. Or we can write here. Yes, we can go to right here. DB1. Channel address. Okay, let's test this one. So I will use the M0.5 here. And I will use one more M1.6. This one reset counter, right? Reset encoder. So we can use like this. Yes, we can use like this. And then we can download. Let online to check. Okay, so we can change this one to be counter db1, right? And then choose the load underscore val. It is the new load right user, new load value. Yes. And then we can save and then compile the project and then let download to the CPU again. Yes. And we can online. Yes. So right now the value is 0. Yes, because M 1.6 is turned on, so I will remove off. Yes. And then we can reset the counter from the HMI, so we can link this one to the HMI. Yes. So go to HMI text, and this one should be reset encoder. So M1.6 100 millisecond also. Yes. Compile the block. Yes. There is no error, and then we can create the push button for enable the counter or enable the encoder and reset the encoder, right? Okay. So first we need to insert the enable encoder or enable the FM, enable switch gate, SW gate, So go to property and then go to apparent, enable. I will use this button and change the text color to be black. Or we can change to be green color. It is the enable switch. And one more button for reset the counter, right? So one button is enable and one button is reset. Maybe I will change to green color. Yes. And this one I change to this color. So normally we will use the red, it means that not yet enabled, and if the green, it means that enable the switch gate. Yeah, so this one should be reset encoder. Yes, and we can go to event and click. So this one we can use invert bit, right? So invert bit, go to HMI, take default, and then we can use the enable. Yeah, this one, enable the counter gate. So drag and drop, and we need to show the color animation also, right? So go to color animation, go to display, insert new apparent, and then drag and drop the text, and we will change the color to be green, right? If the condition is 1, it means that we already enable the switch gate of module. Yes, and for this one we can also go to event and then choose freeze. So set bit when while key freeze, and then I will choose the reset encoder. Yes, so that's all. And then we can test again. Yes, so this one should be, I will copy this text, value of encoder, I will adjust the size to be 25. Yes, change the color to be white. And this one should be reset, enable and reset the counter, right? So enable switch gate, and this one should be reset encoder. Yes, like this. So the picture of encoder we can put here. And then we can save the project and simulation the HMI again. Go to HMI and then simulation. Oh, this one we need to change a little bit, right? The size is so big, the font size. So I will adjust. Adjust this one also. I will adjust the size to be 23. Yes. Okay, good. And then go to simulation again. Okay, so first we need to enable the switch gate, right? So let's go to see the main program and then go to see the switch gate. Right now it's true, right? So if we disable the switch gate, the counter is not working, right? Will not working because it doesn't work with the function without turn off the switch gate. So if I turn off the switch gate, so let's try to adjust the encoder. So let me adjust the encoder. Yes. It will not work, right? Okay. Because we not yet enable the switch gate. So if I enable the switch gate, yes. And let's try again. Okay, let's try to adjust again. Yes. The signal is working. Yes. And the value is increased. Yes. If we rotate fast, it will fast. So if we would like to adjust, decrease or reverse the signal, the value is decrease. Yes. Increase again. And if we would like to reset the encoder, we can push here. Yes. If we push, this one should be work, right? So if I push, yes, it work. But the value still have, right? So let me check again. Why cannot reset this one? Move 0 to 0, and then the new value should be moved to here, right? This one work or not? Move to 0, right? But the value still have. Okay, right now we cannot reset, right? Because we use the incorrect address here. So we need to put the L direct. Yes, so M0.6. I will change this one to M0.6 and then download again. And let's go to online again. Yes. So let's try to reset the counter again. So I will put reset. The value will move to 0, right? Because we use the L direct to reset the counter. Yes. When we turn on this one should be turned on also. Yes. And then reset the counter to 0. Okay. So if we try to adjust again, let me adjust again. So adjust the encoder again. The value is show, right? Increase. So if we decrease, the value will show minus. Yes. And if we would like to show only the positive number, yes, we can adjust here. I will use the function ABS absolute, yes. And then I will choose the temporary variables. Yes. Example temporary one. It is real, right? So we can choose temporary here. And then absolute the value. Okay, and then we can download. Okay, let's see, it is minus 340, right? And this one 340. So if we would like to show only the positive number, yes, we can use this function. Yes. And we also can reset the counter. Yes. And let's adjust again. So if I adjust the encoder, let's see, the value is changed. Yes. So it worked perfectly. So this is a just example about how to read the data from encoder by using the TIA Portal and module FM350-1. Yes. So I hope this one just the example for everyone to practice if we have the encoder and we would like to use with our project. So we can use the example to practice. Yes. And then we can use it. Okay. So for encoder, we can use for measuring the speed of motor or check the another function that we can use. Yes, so many options that we can use with the encoder. So if we would like to use, we can follow my video and then we can create more program to use. Yes, so thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I'm also sorry if I have mistake in this video also. And I will drop the example file under my video for easy to everyone download to learn or to see the status how to edit or how to create the program. Okay, so in this time I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye.